What is nature's most powerful display of force? Is it the furious, spinning vortex of a hurricane? A storm that can churn the oceans and flatten entire communities with its relentless winds? These are spectacles of immense energy, certainly. We watch their approach with a mixture of fear and awe. Their destructive paths are well documented. They carve scars across landscapes and lives. Humanity has learned to respect their terrifying power. Or perhaps it is the sudden, violent shudder of an earthquake. The very ground beneath our feet betraying its solid appearance. Buildings crumble to dust in mere seconds. Mountains can be visibly shaken. The earth groans and splits, releasing tensions built up over eons. These events remind us of the planet's restless, dynamic nature. But what if an even greater, more concentrated force exists in nature's arsenal? A phenomenon that, though rarer, can unleash devastation on an almost unimaginable scale. It is a power born from the deep earth and the vast ocean. One that often sleeps, sometimes for thousands of years, biding its time. This quiet giant can dwarf other natural disasters. This is the realm of the mega-tsunami. A wave not just of water but of sheer, unadulterated power. Imagine standing on the sun-drenched coast of West Africa. The waves gently lap the shore. The land stretches inland, seemingly peaceful and undisturbed for millennia. Yet here, scientists have found something utterly extraordinary. Something that simply should not be. These discoveries challenge our understanding of coastal stability. They whisper of an ancient, violent past. Far from the current reach of the ocean, sometimes kilometers inland, lie enormous boulders. These are not small rocks easily moved by storm surges. Some weigh hundreds, even thousands of tons. They are colossal monoliths, resting incongruously amidst the vegetation. How did they arrive in these elevated inland positions? Local geology often confirms they are not native to their resting spots. They are strangers to this land. These giant stones are silent witnesses. They speak of an immense, powerful force. A force capable of plucking them from their original locations, perhaps near the coast or even from the seabed, and then transporting them high above sea level, deep into the continent. This is the stark evidence of a mega-tsunami. These are not the tsunamis we commonly hear about. Those are often generated by submarine earthquakes. While devastating, they are different in scale and origin. The waves we speak of now are mega-tsunamis. True giants of the ocean, born from events of almost planetary significance. Their genesis lies in some of the most dramatic geological processes on Earth. They are a rare but terrifying product of our planet's architecture. How then are such truly colossal waves brought into existence? The answer frequently lies in the heart of a volcano, particularly oceanic island volcanoes. These majestic peaks rise thousands of meters from the seabed. They appear solid, immutable. But they are not always as stable as they seem. Over vast timescales, their internal structure can weaken. Magma movements and hydrothermal alteration can compromise their integrity. The trigger for a mega-tsunami is often not an eruption upwards towards the sky. Instead, it is a catastrophic failure sideways. An entire flank of the volcanic mountain, a colossal slice of rock and earth, suddenly gives way. This immense displacement of water is the key. The ocean is literally punched by a falling mountain. Fogo's scar, a fiery genesis in the Atlantic. Let us journey to Fogo, a striking volcanic island in the Cape Verde archipelago. It pierces the Atlantic sky, a testament to millennia of volcanic construction. Its slopes are steep, its history fiery. Fogo is an active volcano, a place of dramatic beauty and inherent power. But it also bears the marks of an ancient, colossal catastrophe. One that provides compelling evidence for the birth of a mega-tsunami. This island holds a story of incredible destruction. Scientists believe that approximately 73,000 years ago, Fogo experienced such a catastrophic flank collapse. A vast portion of its eastern side catastrophically failed. An estimated 160 cubic kilometers of rock slid into the deep ocean. The energy released would have been monumental. The island was forever changed by this single, devastating event. Its profile was dramatically and permanently altered. The evidence for this ancient cataclysm is compelling and multifaceted. A massive amphitheater-like scar dominates one side of the volcano. This is the detachment surface where the flank tore away. The devastating aftermath, water's unbridled fury. When such an immense volume of a mountain flank fails and plunges into the sea, the immediate aftermath is almost beyond description. The ocean recoils from the impact, then surges upwards and outwards with terrifying speed. Water, usually a life-giving force, becomes an agent of utter annihilation. The scale of destruction is difficult for the human mind to fully grasp. It is nature operating at its most extreme. Walls of water, potentially hundreds of meters in height, can travel across entire ocean basins. Upon reaching distant shores, they do not merely break, they overwhelm. They can surge many kilometers inland, scouring coastlines completely bare. Forests, settlements, entire ecosystems are obliterated in moments. The erosive power is immense, stripping soil down to bedrock, leaving behind a landscape utterly transformed, barren, and desolate. The very shape of the land is redrawn. Life in the path of such a wave stands little chance. The force is too great, the warning too short, if any. Section 6. Modern Echoes and Looming Dangers, Present-Day Perils. Are these colossal flank collapses and their resulting mega-tsunamis merely relics of a distant, more violent geological past? It would be comforting to think so. However, the Earth remains a dynamic, ever-changing planet. The forces that shaped Fogo are still at work today. Several volcanic islands around the world currently show signs of instability. They are being closely watched by scientists. The threat, though perhaps infrequent, is undeniably real. Indeed, modern environmental changes might even exacerbate these risks. Climate change, for instance, is causing glaciers to melt at an accelerated rate. This removes weight from volcanic edifices, potentially leading to isostatic rebound and destabilization. Rising sea levels can also affect the stability of coastal volcanic slopes and underwater flanks. Furthermore, active volcanoes often build unstable lava deltas that can collapse into the sea with little warning, generating significant local tsunamis. We have witnessed glimpses of this terrifying power in more recent times. Consider the event in Lituya Bay, Alaska, in July 1958. Beneath our feet, a call for vigilance and understanding. These immense geological events, the collapse of volcanic flanks and the generation of mega-tsunamis, are thankfully rare occurrences on human timescales. However, their potential impact is so catastrophic, so utterly transformative, that they demand our serious attention. They represent some of the most extreme natural hazards our planet can produce. To ignore their possibility would be a grave oversight. We must strive to comprehend these sleeping giants. Understanding the complex geological forces at play within these volcanic systems is therefore of paramount importance. Scientists employ a range of techniques to assess the stability of volcanic islands. This includes GPS measurements to detect ground deformation, seismic monitoring to listen for internal stresses, and detailed geological mapping. Identifying precursor signals, subtle signs of growing instability, is a key goal. Early warning, if possible, could save countless lives. We must continue to listen intently to the Earth's subtle whispers. The almost imperceptible shifts in the ground. The changes in gas emissions. The patterns of small earthquakes.